in your brain. You can go play with it after class. Goof around with a little bit. It's logic. And logic is pretty cool. First of all, don't between this and what we're going to talk about first tomorrow, don't get the idea that I'm in any way, shape, or form anti-Crestron, anti-AMX, anti-Medialon, whatever. Extron, all those guys. I love them all. They're great. However, I think there are some situations in which we don't need to have our customers giving them money. I like it better when our customers give us money. Right? I mean, come on. So, wait a minute. Add another. I always forget this design file does not have all of the things it needs. It has almost all the things it needs. Okay. Let's share the screen. I almost shared the little clock with you again. That would have been brilliant. Here's your full screen button. Come on, there we go. Okay. In any London device, you have the configuration window where you can right-click and put in audio processing objects. Right-click, new, dynamics. Oops, right-click, new, dynamics, Ducker. Be cool, right? Right up here above the rack view. Not looking, look right there. It says logic. Click on that. You've got a logic configuration page. You can right-click, new, source. Be cool. Right? Now, I've taken a bunch of logic objects and I've placed them in this design file. Okay, this is no different than if I were showing you processing objects I'd pre-placed. Instead, they're logic objects. Okay? And I've kind of divided them up because I want you to understand the conceptual relationship between some of these. Because the 5 on the left there in the top are all objects that start logic. Logic source, logic pulse, logic calendar, comparator, and value. Those all provide the beginning of a logic chain. 4 over here provide the end of a logic chain. And everything else is the middle stuff. And we're going to discuss them bit by bit. But first I want to show you how logic works. If I have a logic source and a logic end, and I could have right-clicked to place these, but the reason I didn't, is you notice it says logic source right there? If I right-click, these all come in at their smallest possible size, and you can't read what the heck it is. So I've resized them, made it a little bit bigger. I'll copy them from up there instead of right-clicking and placing them. But I could have right-clicked, same difference. If I have a source and an end, the source has a control panel, the end has a control panel, and if I go up here and turn the button on the source, the end turns on. And the little purple lights light up over here. If I turn the source back off again, the purple lights go away, the end turns off. Yeehaw. If I have a region meter on a control panel, I grab this logic end and drag it up there onto the region meter. Then when I turn on this button, region meter comes on. Cool. Turn it off, it goes off. My computer catches up. Come on, computer. There we go. Turns off. That's how logic works. Something turns on a source or creates an event which drives an end or something else at the other end of the chain. Everything else is icing on the cake. Cool icing, but icing nonetheless. Wish my control panel would fit. Wait. Oh, there we go. That's what the problem was. Properties was too fat. Okay. Now, I can associate these logic sources and logic ends with control panel objects. You saw me do it by dragging the logic end control panel object onto there. Well, instead, what I can also do, replace that with a blank one, there we go, is I can take the audio control that I want, and I can drag it down until I get the little green outline there, and release it, and that means I just linked that logic source to that mute. If I go to the design tree It actually shows up on a link right there. I can grab this master mute and drag it down to the logic end. And now it's linked. And what's going to happen is when I turn on this channel 1 mute, master mute goes on. Turn it off, master mute goes off. Right? Excuse me, 1 second. The frog in my throat apparently grew claws right about then. Holy cow. I'll be fine. Fine me. So those two things are linked. Okay, big deal. That's nothing terribly impressive. I could have just linked the stupid buttons together and accomplished that. It's the stuff in the middle that makes the magic. Like these 5 objects here. They're called Boolean objects. Go over here to another device where I have them pre-laid out to show you something here. Boolean objects change their output based on certain input conditions. The AND object will turn on its output when inputs 1 and 2 are both turned on, like right there. The OR object will turn on its output when either input 1 or input 2 is turned on. The NOT object just reverses whatever the input is. The NAND and a NOR, the AND turns on its output when both inputs are on, right? The NAND turns off its output when both inputs are on. So by combining these together, we can build all kinds of more complex logic. For instance, just for instance, let's take a logic AND and stick it on here. And let's copy another source in here and link the other source to mute channel 2. Come on. No. By the way, even though we only have 43 minutes left in class, I'm predicting that my computer will crash before class is over with, because the training software is acting just stupid right now. Lagging out like crazy. So if it does, I'll be right back, I promise. So now what's going to happen? Logic end, which drives this master mute, is going to be on when input 1 and input 2 are both muted. If I unmute either one, master mute turns off. Cool. All right. Still not the most horribly useful thing in the world, but kind of cool. Now, let's build some other circuitry here. Let's take a logic pulse and a logic end. You know what a logic end does, right? Just a little display and allows us to link to things. Get over here. And if we tie this logic pulse to it, what's a logic pulse do? Well, a logic source turns on when the object linked to it is turned on, or when you turn its button on, right? Logic pulse turns on for this many ticks and turns off for this many ticks. And a tick is 100 milliseconds. Right now, it's going on and off every half second. You guys probably can't see that because it's flashing too fast. Training software can't keep up. If I slow it down to a 1 second on-off, then you'll start seeing it flashing on and off on your screen, making the logic end flash along with it. If I take the logic end, just like we did before, tie it to my region meter, now I've got a flashing red light on my control panel. Okay, what the heck good is a flashing red light? Well, let's integrate these two circuits together. Let's drop an AND in here. Wire it up. And let's drop a NOT in here and wire it up. And what is this wire right here? This wire right here is our master mute, right? It's always going to be showing us the condition of our master mute. If I do this, when is that red light going to flash? That red light's going to flash on when the pulse is on and not master mute. Red light's going to flash when the pulse happens and not master mute. So in other words, I've got an on-air indicator. Whenever the master mute is open, the red light flashes. Now, I could take that logic in and tie it to a logic out on the device, and now I've got an on-air real-world indicator. I can tie it to a LED, tie it to a flashing light in the real world. That's kind of cool. But change this logic pulse. Really long off time. Can't really make it that long, but I can make it 32,000. Because I don't want that red light flashing on my screen the whole time. It's going to drive me crazy. You got the concept. So what else can we do here? Well, we have some other objects we haven't explored. What about the calendar object? Well, this is a real example of a calendar object use. This entire circuit is, actually. This circuit is for it's like the world's smallest conference room. I don't know, I've seen closets a lot bigger than these, man. They couldn't be, I'm trying to picture in my head, it can't be 6 foot by 6 foot. It's not even that big. These little tiny rooms with doors on them in a library, it's university. But each room is to some degree soundproof. You know, it's not like a music rehearsal room or anything. But in each room is a pair of Control 23 JBL speakers wired up to a sound web. And I don't remember what kind of amplifier it is. One of the Crowns, probably an 8200. I'm not sure. And they have a LCD mounted in the wall, a little 14-inch LCD with a VJ input down there and an RCA input and one of the little Extron panels, right? And they use these rooms. This university does a lot of multimedia stuff. And they use these rooms because when you plug into that wall plate in this little room, it's exactly the same as plugging into the wall plate in their classrooms and their presentation rooms. So you can bring your laptop or your DVD player or whatever it is you're using for your source material, plug it in and practice your presentation, and know that this little room is going to react just like the room you're in. They do tons of these things as part of their curriculum. It's major credit. They have to have a room that acts like the real room. But the problem is, these little rooms, there's, I don't remember, 14 or 18 of them, something like that, are downstairs in the magazine area of the library, where there's not always staff on site. The staff's only there from 8 to 5. So outside of those hours, they don't want these rooms to work. They want the audio to not work in these rooms so that students aren't down there in the middle of the night with their iPods blowing these rooms up. Okay? Well, yeah, we could fix it with a limiter, but the customer said they wanted the room to not work at all. No audio from 5 p.m. to 8 a.m. No problem. This line right here is the master mute, right? I'll pull this back. I'll throw an OR in there. Wire it back up. So, now, when is the master mute? Oops. See, my wire just freaked out on me. It was all courtesy of the training software sucking up CPU cycles. There we go. When is this master mute going to turn on? Master mute is going to turn on when channel 1 and channel 2 are both lit up, or when the calendar tells it to. So how do we tell the calendar to tell the master mute to come on? Well, there's no control panel for it. Like most logic objects, we have to control it with properties. Go over here and we double click. And we say at 5:05 p.m., starting on May 1st, turn on the master mute and recur every 1 day. Then we double click again and we say at 7:55 a.m., starting on May 1st, turn off the master mute. Recur every 1 day. Let the training software catch up. Still letting the training software catch up. Come on, you can do it. There we go. So now we have a calendar object. Turns itself on at 5 p.m. and off at 8 a.m. with a 5-minute buffer. Now, when is 8 and when is 5, and how do we do time? Tools, File Preferences, Time Zone. Because when you go online to your computer, to your SoundWeb system, your computer tells SoundWeb what time it is, GMT. You have to tell your SoundWeb which time zone it's in, so it knows how to offset that. So I tell it I'm in GMT -7. Do adjust for daylight savings time, US and Canada. Hit OK. Now it knows what time it is. Now, if I bring up my Windows clock and calendar, which I know you guys can't see, but that's the standard Windows dialog box that you just can't see it. And if I tell my computer that's really 7:26 p.m., I hit apply, watch that little black dot right there on the calendar object, it's going to turn purple. That's after 5 p.m. If I change my clock back and make it before 5 p.m., it turns back off. So after 5 p.m., calendar object locks out the rooms. How cool is that? Now, if you have a spec come across your desk, and that's one of the things they're asking for, what's the first thing you normally do? Down the hall, the guy who knows about Crestron, and you say, how much is this going to cost? How much extra stuff do I need for this? Make these rooms turn themselves off at 5 p.m. and back on at 8 a.m. Well, now the answer is nothing. It's not going to cost you anything. It's already built into the DSPs. Along with, a couple of million other possible uses, the logic program, or logic segment. All kinds of cool stuff with it. So don't assume that you need Crestron, AMX, Extron, whatever, to perform functions. Now, if somebody wants a 15-inch touchscreen built into their wall, well, you're kind of going to have to go Crestron for now. Unless you can find a PC that you can build into the wall with a 15-inch screen. I know of one with a 10-inch screen, but none of them as big as 15. But for a lot of functionality, SoundWeb can do it by itself. The logic source links to a button, right? Any binary object, any button, switch, anything with a on-off setup. There's also a thing called a logic comparator and a logic value. And they're the same thing as a logic source. The difference being the logic value works on source selectors. If I link this source selector to the logic value, I have to reset it because there's no hardware involved here, but if I go to the first source, I get the first light. If I go to the second source, I get the second light. All there's to it. So now I can trigger logic functions off of what my source selector is set to. I want to trigger logic functions off of a fader or a rotary. Grab it, drag it over, and drop it onto the comparator. The comparator has a control panel. Because the control panel will tell us two things. What's the current value of the fader? As I move it, you see that number updating itself much more smoothly on my screen than yours. So what's the current value of the fader? And what's the compare value? If I hit the copy button, it'll stick the current value into the compare value. And then under properties, I tell it what to do with that compare value. In other words, I can say greater than or equal to, which means if I'm greater than or equal to, if my input is greater than or equal to my compare value, then turn the silly thing on. If it's not, turn it off. And signed means I'm going to deal with plus 1.6 dB and minus 1.6 dB as two different values. Now I can also set this thing up so it'll trigger anytime I get more than 5 dB away from 0, either direction. Either one. I'm going to leave it signed for now. 1.68 is my target. Watch, I'm below 1.68 and it's turned off. Go above 1.68, now it's turned on. If I want the end user to be able to control that set point on a day-to-day basis. A good example of that is if I tie the logic comparator to a logic end, grab the indicator off of that, drop it in here, get over here. And we can fancy this up a bit more if we wanted to, but I'm not going to bother for now. We'll change that on color to a nice bright yellow. Put this sucker to the back. Grab the copy indicator and put it up here on top where it's useful. Come on, you can do it. There we go. Now what I have is little yellow highlights that pop up whenever I'm above the preset value. And I can change that preset value using that button. If I want to change it to negative 3.43, I hit the button. Now at negative 3.43 or above, get the yellow highlights popping up, my little Mickey Mouse ears, tell me I'm above the value. So I can set little reminders for myself on the control panel. You can put this wherever. You know, this could be actually sitting here if you wanted to. You pop up little reminders to yourself. Oh, you know what? That's right. I didn't want to push that past negative 2.47. Or trigger anything else you want off of the position of a fader or a rotary. I know one guy sets these up with rotaries all the time. He has a little red light above every pan knob, and the little red light lights up when you're at exactly center on the pan. It's like, you know, it's kind of cool and kind of geeky, but it's also a lot of work because you're sitting there trying to tweak that knob to exactly the center. And I asked him, you know, why don't you just put a little button there instead of a little light? A little tiny button, and when you tap the button, it goes to straight up and down. He kind of looked at me and he's like, oh, yeah. Easier, wouldn't it? So be careful with logic and make sure you're doing something you need to do, not just because you can do it. No, but this can be useful. You can also set it to equals. Be aware of the fact that if you set it to equals, it's really touchy. It's really hard to get that exact value. Almost impossible. But it can be done. And see, this can also be very useful. Let's say you had one of these little indicators on every channel of a mixer. Okay? And those positions, you know, you do your sound check. You just go through and you tick each pin. Because wherever your sound check level is, you go tick. Go right across every channel. Bing, 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 bing. And then you go and mix the warm-up band. Warm-up band is done. You move all your faders until the little light comes on. You're back to your sound check position. Somewhat useful, yeah? Enough for the logic comparator already. Good grief. So those are the things you start. That's how you start a logic chain. In the middle, we've already played with the Boolean objects. In the middle, we also have other objects like the counter. The counter trigger has a number assigned to it. You can set that number. Gosh, how high does it go? 32,000? Yeah. 1 to 32,000. And what happened is, we have the logic pulse ticking off every 1 second over here. We have a logic source tied to the R, which stands for reset. As long as the reset is held high, nothing happens. If I turn off the reset, 1 pulse, 2 pulse, and yours is slightly later than mine, 3 pulses. On the 3rd pulse, the output goes high and stays high. It'll stay high until I turn the reset back on. All right, cool. Also the counter shifter. Binary or shift mode. I can have up to 32 outputs. Has a D for direction, an R for reset, and an input. And if the reset is on, nothing happens. So I turn off the reset, it starts counting. Funny thing for a counter shifter to do, huh? It starts counting and shifting. If it's set in shift down mode, which is set over here in the properties, shift down mode, it just counts straight down. Binary mode, it counts in binary. There's 8, 9, and actually it's one more than that, 11. Counts in binary for you. All kinds of cool stuff with that. Logic delay. The biggest thing with the logic delay is that it does not work the way your brain thinks it does. It has nothing to do with an audio delay. Logic delay has a delay on and a delay off. If I set the delay on for 3 seconds, go over here to my control panel and I go tick, the input turns on, and 3 seconds later, the output turns on. Alright, my delay off is set to 0, so I turn it off and the output goes off right away. Okay, that makes total sense. Let's reverse them now. Delay on is 0, delay off is 30. If my delay on is 0 and I turn it on, tick, it turns on right away. If I turn it off, seconds later, the output turns off. Pink. So far, it looks kind of like a funky audio delay, doesn't it? But here's where it gets weird. Turn it back on. Turn it off. Turn it back on. 3 seconds later, nothing happens. Turn it off. Turn it back on. Oh, the training software locked up, didn't it? Hang on. Turn it off. Come on, there you go. Turn it on. 3 seconds later, nothing happens. On delay does not mean, turn it on, I'll turn the output on 3 seconds later. It means if the input is on for at least 3 seconds continuously, then I'll turn the output on. Just like delay off does not mean turn it off on the input, I'll turn the output off 3 seconds later. It means if the output is off for at least 3 seconds, then I'll turn the output on, or output off. That 3 seconds obviously is variable. You can assign it whatever value you want right there in properties. Most common thing I do with the logic delay, man, I put it on 5 seconds on every job. This logic source is tied to that normally closed contact from the fire department or fire panel, one that always freaks out and glitches constantly. Then the logic end is tied to whatever I'm supposed to do when the fire alarm goes off. I go to the fire marshal and I say, listen, is it okay if the audio system responds 5 seconds after the fire panel goes into alert? No problem. I've never had a fire marshal say no. What that means is when I lose my fire connection and get it back, the audio system doesn't freak out. How many times have you been sitting on the job site and you hear beep, beep, and then it stops? Somebody's screwing around with the fire panel, trying to get it configured. 3 minutes later, beep, beep, then it stops. But you have to either disconnect your wire or have a circuit like this in it. Give you a 5 second delay. Now sometimes when they're testing the fire system, you'll get a full longer than 5 second glitch, but not usually. It saves you quite a bit of headaches. The logic delay deals in pulses of 100 milliseconds. Those pulses are not accurate because those pulses are counted by the system CPU. Logic is the least important thing that ever happens in the system CPU. Presets are more important. Serial control is more important. Everything else is more important. But 100 milliseconds could become 102, 105, 104, 103, 106, 107, 101, whatever. A little bit longer. So whenever it gets around to it, it finally does it. If you need a long, and for short things, 30 pulses, 50 pulses, 3 to 5 seconds, who cares? So maybe it's off by 1/10 of a second, big deal. If you want to do longer delays, you want to do a 1 minute, or you want to do a 20 minute. Well, a 20-minute delay that's off by 10% is pretty significant. A 20-minute delay that's off by 5% is pretty significant. Because now it's 21 minutes instead of 20. Oops. For that, you use the logic timed delay. Where is it? Right there. It's the exact same thing, but instead of working in pulses, it works in 1 second chunks, And that 1 second is read off the system clock. It's not timed by the system clock like the 100 milliseconds are. It's actually read. So when the on command comes in at 47 seconds after, the off command triggers at 54 seconds or whatever. The single pulse trigger we're not going to go into very deeply. Give me a call if you need something converted to an off-on-off pulse. And by that I mean, let's say the signal you're getting is a stutter. It's pep, 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 pep. Or the signal you're getting is a press and hold. Or the signal you're getting is a release and hold. And what you need is off, on, off. Single pulse trigger will take any of those combinations and about a dozen more and convert it to an off, on, off pulse. One example of that is the contact to infrared converter from Xantech. That thing actually squirts the IR command out when you release the contact. So if you have a button on a touch panel in London controlling a control port, which is controlling that converter, and somebody puts their finger on the touch panel to push the button, nothing happens. Nothing happens until they release that button, which is kind of freaky. It can kind of, feel weird. Makes the control panel not feel friendly. Put the single pulse trigger on there, they press and hold the button, single pulse trigger spits out a 1/10 of a second pulse, the IR takes off like it's supposed to. Just one example. Also in here, we have the truth table and the logic coupler. The truth table takes a set of binary inputs and maps it to another set of binary outputs, whatever you want it to be. It can control functions based on rooms opening and closing, functions based on which options are turned on or turned off, all kinds of things. Logic coupler is just there to make copy and paste easier. You can drag it over, hold the control key down, and copy that stuff over. It gives you a nice, fast way to do copy and paste. And especially in Logic, you quite often have 20 rooms that all get the same functionality. So you just build it once and copy and paste it and reassign everything. A couple more logic objects. There's also the event log monitor, which is a new object. It is not used to monitor the event log, oddly enough. It is used to monitor crown event logs. This allows you to trigger functions in Logic off of power status of crown power amps, or thermal status, or impedance, all that kind of stuff. We'll monitor event log issues on a crown power amp. There's also the priority encoder and the snapshot command. Priority encoder, it allows you to prioritize logic lines. What it was originally created for was setting up priority paging zones, where if you've got, say you have 3 different paging mics at an airport. One paging mic is in the general office, and when they page, it pages the entire airport. And the second paging mic is for just concourse B. And the third page is for just gate number 47. So when somebody pages the entire airport, for instance, that comes out of all the speakers. Unless gate 47 is busy paging, in which case it doesn't go in. Gate 47 takes priority. Or if B is paging, or whatever. It allows you to prioritize things like that. I'm not going to get into the functionality of it because it'll just melt our brains down, but you get the basic idea. If you need it, let me know. I'll give you a more in-depth explanation. Snapshot allows you to record and recall states of logic signals. Again, this was created for one specific purpose, but it can be used for all kinds of cool stuff. The purpose it was created for was if you have, let's say you have 16 paging zones around the outside of a stadium. And normally you want to page into only certain zones. But let's say for today's event, you want to be able to repeatedly page into the south half of the stadium. Well, you can go in and turn on south 8 zones, and then store that into the snapshot. Anytime you want, you hit the recall button for snapshot 1, and it recalls those settings for you. Pages into those zones. All kinds of other stuff you can do with it based on whatever your logic system is supposed to be doing. Have it reset all kinds of stuff for you. I'm going to show you the device monitor last. Skip that one for just a little bit. The last thing I want to show you before we change design files is there's an audio object called the meter trigger. And it's an audio object designed to work with logic. Meter trigger has on it a little trigger light. And you take your logic source, and you take your trigger light, you drag it over, and you link the two of them. As soon as the training software catches up with me, it'll work great. Here we go. You link the two of them. And once they're linked, the trigger light will turn on whenever that meter is above 0. That will turn the logic source on. That'll trigger whatever it is you want to do in logic. And remember, this is an audio object. It's actually reading your audio. It's very important to pay attention to what I said. The trigger light will turn on whenever the meter is above 0. I didn't say when the audio was above 0, when the meter is above 0. It's just a meter. If you want the trigger light to come on at -3, set the release to the reference to -3. Now the meter will say 0 when the audio is at -3. Want it to trigger at +7.4? Set the reference for 7.4 dB. Now the trigger light will come on when the audio hits 7.4 dB. And you can tweak the release and the attack to determine how this responds to transients and that sort of thing. And your logic source will do its thing and trigger whatever logic you happen to have programmed. That's pretty cool. Any questions on that? We had a question on how to interface with control ports. Let me show you that real quick. Logic source, logic end. Tie them together. And let's go to the design tree, devices, blue 16s. First blue 16. Normally we find control ports under default config control ports, right? But those control ports are for audio processing objects, not for logic objects. The whole reason for that, which I'll explain if you'd really like to hear it, but if not, let's just move on and say it's not there. It's under logic instead. Logic control ports. If I want to input 1, a contact closure to control this logic source, I grab the button, drag it over, drop it on. Done. Problem solved. I want this logic end to light up an LED, drag it over to output 1, hit OK, done. Now output 1 will go high when that logic end goes high. This logic source will go high when input 1 goes high. Nothing to it. Any other questions on logic before I show you the device monitor? All right. Get a new design file in here. Yeah, I need 3 volunteers from the audience. Blue aid number 1, blue aid number 2, and blue aid number 3. And in the logic section of blue aid number 1, I'll put in a pair of device monitors. And the first device monitor I will assign to blue aid number 2. Second device monitor, I'll assign to Boolean number 3. If I wanted to, I could have used HiQNet node address instead of the device name to assign it, which means I can assign the device monitor to monitor any HiQNet device as long as that device implements the monitoring function. And what this device monitor does is basically ping the device. Every 2 seconds, let's set to over here, it sends a message saying, hey, you still there? And as long as it gets a response within 5 seconds, leaves the lights on. Leave the light on for you. Now I just realized that I can't show you guys this without sitting through the entire firmware process for those devices, so let me very quickly do the same thing on my other computer. Won't take but a moment. That's why everybody needs 14 different computers laying around their office, just in case you're stupid. Have beta software loaded on one of them. Oh, but you know what? Before we go, I'll show you a feature that's coming in the next piece of software. As long as you promise not to get me fired for showing it to you. Something that's really simple and really, really cool. Device monitor. The device monitor. Set that one for device 3. That one for device number 2. Fine. You can stop sharing with this computer. And start sharing this computer. Second here. Turn that on. Turn that on. Go back to here. Alright. There's our 2 device monitors. And I'm online. I loaded the design file. You notice they both have their little purple light on, right? Let's say device number 2 and device number 3. Here we go. Network cable for device number 2. I just unplugged it from the switch. 5-second timer runs out. Device number 2's monitor turns off. It's not there anymore. I'm still pinging it though every 2 seconds. I'm still sending a message saying, hey, you there? Are you there? Are you there? So if I plug that cable in, there it's plugged in. There the monitor comes back to life. That's what a device monitor does. Making sense to you guys? Questions on logic before we wrap up the day? Alright, I'll show you one little teaser. The new software. Don't tell anybody I showed you. Now, when we're dealing with 8 channels at a time, this is mildly a big deal. Let's say I wanted to wire these 8 inputs to each one of these outputs. Okay? It would take me 1, 2, 3 clicks. Then I'd have to go 4, 5, 6, 7. So 4 clicks for each one of these. 4 times 8 is 32. I don't know, like 37, 38, 39 right now, right? Then I have to go 1, 2, 3 for each one of those. So 3 clicks for each of these. So it's 8 times 7 is 56, plus my original 4. About 60 clicks. Wire this up to all these outputs, right? New version. 1 click, 2 click, 3 click, I'm done, right? 1 click, 2 click. Hold down the Z key, 3 clicks, 4 clicks. When I click right there, it ties them all together. Isn't that cool? So what would have taken me about 60 clicks previously, I could do in 9 or 10, something like that. Look how fast I wired that up. Oh my gosh. If your design files don't use this type of wiring, you probably don't care. If your design files do use this kind of wiring, tell me you're not drooling right now for this feature to come out. It's cool. It makes things so much faster. And bearing in mind, those 60 clicks we just talked about, if each of these were 16 channels instead of 8, it would have been 16 times 7, which is, what's 16 times 7? 112? Plus your original 3. And to do it this way, it's still only 10, even if it's 16 instead of 8. So there's your little sneak preview of up-and-coming new version of software. When's it going to be out? I have no idea. Almost done. Be too much longer. Any questions? All right. There's that link. You know what? I'm going to, when I close the room, I'll make that link pop up for you. How's that sound? That'll be groovy. Webtraining.com/class.